Similar triangles by Jack Montgomery. Overview. Similar triangles just means that they're the same shape. A different size triangle, if it's a similar triangle, always have the same angles and a common ratio for line lengths. So if we look here, we have two right triangles. And these two right triangles will have all the same angles and their lengths will be proportional to each other. Here we have an equilateral. Here we have a right triangle. So they're just not similar because they're complete different triangles. Properties. Angles are going to be congruent, so they always will be the same. And the sides are going to be proportional. Similar triangles is the angle-angle theorem. If all the angles are congruent, the triangles will be similar. So here we have equilateral triangles, so they'll always be 60, 60, 60. And we don't ever have to, like if we're looking for two angles, you just add them up and subtract them from 180, and it gives you your third one. Okay, here's an easy problem. I'll give you guys a couple minutes. Alright, here's a hard problem. And remember, you only have to find two angles, so you should be able to figure this out pretty quick. Okay, similar triangles, the side, side, side. If you have a triangle, half the size of another one, and they're similar, they need to be half on all lines, but the angles will stay the same. If the length is 4 on one line in a similar triangle, the bigger one needs to be 8 if it's going to be twice the size. If it's 3 times the size, it needs to be 12, and so on and so forth. And all the lines have to stay proportional to this. Okay, so poly 2, this one, is going to be twice the size as this one. So find the angles, the line lengths. This one's going to be tricky, so you're going to have to set up ratios to find out if the lengths are common or not. Types of transformations. Translation, it moves a shape around a plane, not changing angle or side length. Reflection, it reflects a shape across a plane, keeping it just the same in a different coordinate. Dilation, the effect of a dilation is to preserve angles, multiplies lengths by a common ratio. So it's going to make it bigger or smaller. Ratio, rotates a shape around a given point. Just moves it around a plane. Okay, here's a translation problem. Here's a reflection problem. You have the easy and the hard down here. This is dilation. So you're going to make this one bigger. You're going to make this one smaller. Rotation. Rotate this one 90 degrees around the origin. Rotate this one 440 degrees around the origin. Alright, thank you.